session, we are going to discuss about the case study on VLSI. Before that, we should discuss about the small introduction about the VLSI. Okay, what is meant by VLSI? Any of you guys?
Sir, VLSI is nothing but a concept in electronics and communication field, which is nothing but very large scale integration. It is
we can use millions of transistors to complicate circuit into small circuits.
Basically to make a big one to a small one, sir. That is the main objective for this.
Where we are using?
Sir, in many industries, sir, in biomedical fields or in any
mobile
industry,
fields and laptop chips.
Main purpose for the VLSI?
To improve the efficiency and reduce the size of the
and to increase the power also, sir.
Okay, let you start.
Coming to the VLSI case in discussion, ECG, electrocardiography, is also a critical tool. It is used for monitoring cardiac health, especially in wearable and remote health devices. But coming to the discussion about the VLSI, in the basis of electrocardiography, ECG. It is a critical tool used for monitoring the cardiac health, especially in the remote and wearable devices. For traditional software-based ECG signals will be consuming the more power, and it will be unsuitable for battery optimized embedded systems. In this case study, we are going to design and implement a low-power VLSI architecture. It is tailored for especially for the real-time ECG signal processing, and it is aiming to minimize the energy consumption and maintaining its performance accuracy and efficiency. This covers the applications in the fields of wearable cardiac monitors and telemedicine systems.
Next, coming to the problem statement part, designing an ECG signal processor that operate the real time within the string and power and area constant remains a challenges. The processor must handle noise removal. The processor must handle the noise removal, future extraction like QRS detection and signal conditioning while being the suitable for implementable or portable devices.
Then coming to objective parts, to design a low power digital electronic circuits, the ECG signals, to implement the noise cancellation techniques by many softwares, etc. Then moving to design a ECG signals for real-time digital applications, and this ECG is applicable for tools like FGPA or AISCA, and the real-time applications should be used in using the ECG signals.
Also to envelop a power area and performance matrix of the architecture also in objective point of view, and then to synthesis and stimulate the mainly using FPGA and or ASIC tools in VLSI.
At a particular time, power and area and performance. In this, any two only can be increased. Either otherwise, automatically the another one comes to decrease.
And next, system architecture. And system architecture modulation is first. In ECG signal, analog to digital converting signals is mainly used in ECG. Why ECG are mainly rolling a play? What chips are using in ECG? What is LSM adaptive filters?
LMS adaptive filter is used to remove or cancel the power line interference adaptively.
And what is mean by output model?
Send processed data to the storage or display to display the output.
Yeah, its signals are using in ECG signals. What are the ways heartbeat or anything in muscles or any waves come into digital outputs or any other outputs in ECG monitoring or any others. And design flow. We have designed a ECG signal. We want to design one output, or we give an output, it will come as an output. It will implement in ECG or any other implementation plan. And we are using design flows using MATLAB or using Verilog codes or VHDLs or anything. We are using
mainly using synthesis and place and rotate for using Snapsys and cadence tool
to simulate the synthesis. We are using VLSI platform. These codes are very important to roll it. Thank you.
In resultant analysis part, we analyze the clock speed from 10 to 50 megahertz and we are applicable in real times, and power consumption is less than 5 milliwatts, and in area utilization, the minimum gate counts as like sharings and pipelines. In accuracy, it has 95% accuracy in R-peak distortion, and in MIT and DIT database. In lattice, it has 100%. Thank you.
So to conclude this case study part, we should know about what is VLSI. So VLSI, in the starting I said that VLSI is a large scale integration which is used to make a complex circuit into a small one, which should be in which has been created in a small hair type. So in the introduction they have said about the what are the main use of VLSI and where we use these fields of VLSI in electrical fields and as well as in biomedical fields. And in these current applications, we use CAD tools, Synopsys tools, and ANSYS and Simon's tool to operate these among these VLSI tools. So we have more parts such as RTL to GDS to flow, and synthesis part, floor planning and grounding, etc. So in actually VLSI is getting part in the basis of 3 types. What are the 3 types? Speed, power, and area. By reducing the area and increasing the power, we can calculate the speed and efficiency of a system where we need. So on the ancient times, we have a computer in a room size. Now it is coming under our hand. So this is the evolution of VLSI. So anybody know the evolution of VLSI? Small scale integration,
And
MSI, LSI, VLSI, and the next evolution is going to ULSI, ultra large scale integrations. So the combination